In this video, we'll explain the differences between a closed circuit and an open circuit cooling tower and the advantages and disadvantages of each. How do you know which type to use for a project? They both provide heat rejection, but in slightly different ways. These systems are often referred to as open and closed loop systems. These are the two commonly used HVAC cooling tower system designs. Closed loop versus open loop operation. In a closed circuit cooling tower, the process fluid, which could be water or a water glycol mixture, is circulated within a closed loop piping system. There are two separate water sources, one external within a closed loop and the second one that circulates water from the tower basin over the heat exchanger. There is never any contact between the water in the enclosed loop and the water circulated within the tower. The water in the tower basin is pumped up and sprayed over the coil that is fed from the closed loop piping, while a fan forces air over the wet coil. This increases heat transfer through the coil while minimizing the evaporation of water from the basin. The cooled water in the closed loop coil returns to the building to absorb more heat. Return air brings heat from the space over the indoor coil. The refrigerant cycle moves that heat to the water-cooled condenser coil, where the water circulated from the cooling tower picks up that heat. The heat is pumped to the cooling tower's closed-loop heat exchanger coil, where water is sprayed over it as air is induced or forced over the coil. Open circuit cooling tower. In an open circuit cooling tower, the water is directly exposed to the outside air. Water enters the top of the tower and is sprayed over the fill or heat transfer media. The exchange of heat occurs directly between the water and the entering ambient air. The water that is circulated to the chiller's condenser and the air within the tower touch each other. This increases the chance of contaminants being scrubbed out of the air and into the cooling tower basin. The water in the basin is then returned to the facility or the condenser side of a water-cooled chiller, which could foul the chiller's condenser coil if the water is not properly treated. The makeup water to the tower can also introduce contaminants to the process water. Induced draft versus forced draft. There are several tower configurations, including induced draft and forced draft. The fans for an induced draft tower are located at the top of the tower and induces air into the tower. The fans for a forced draft tower are located at the bottom of the tower and forces air into the tower and over the coil. Closed circuit cooling tower advantages and disadvantages. Closed circuit cooling towers, also known as evaporative fluid coolers, play a critical role in the operation of water source heat pump systems in the HVAC industry. It's important to use a closed loop system because the water is circulated into the coils of all the water source heat pumps scattered throughout the building. Sending water from an open tower into all these remote coils could create a maintenance nightmare, along with a reduction in efficiency for these units. Advantages of a closed circuit cooling tower. Number one, reduced risk of contamination since the process fluid is isolated from external elements. Number two, water conservation as the process fluid is recirculated within a closed loop. Number three, less susceptibility to scaling and fouling due to the closed nature of the system. Number four, reduced equipment maintenance. Number five, reduced water treatment costs due to lower volume of water circulated from the basin. Number six, sensible heat rejection with pumps off, saving additional energy when conditions are right. Disadvantages of a closed circuit cooling tower. Number one, typically higher initial costs due to the need for additional equipment like pumps and heat exchangers. Number two, requires maintenance of the closed loop system to prevent corrosion and ensure fluid quality. Applications. Closed-circuit cooling towers are often preferred in applications where water quality is critical and there's a need to minimize the risk of contamination. This makes them suitable for water-cooled heat pump applications in those industries with strict quality standards such as laboratories and data centers. Open-circuit cooling tower advantages and disadvantages. Advantages of an open-circuit cooling tower. Number 1. Generally lower initial costs as there is no need for additional closed-loop equipment. Number 2. Simplicity in design and operation. Number 3. Large range of capacities and configurations. Number 4. Energy efficiency. Disadvantages of an open-circuit cooling tower. Number 1. Greater susceptibility to contamination from external elements like dust, debris, and biological growth. Number 2. More water consumption as water is continuously replenished and not recirculated. Number 3. The requirement for water treatment. Number 4. Extra level of maintenance. Number 5. Reduced efficiency due to the scale and/or fouling of the chiller's condenser coils if water treatment is not properly maintained. Number 6. Complicated design when tower is installed below the piping system or pump. Applications. Open-circuit cooling towers are commonly used in the HVAC industry where water quality is less critical and the focus is on cost-effective cooling. They are found in all types of buildings spanning the HVAC industry. The addition of a heat exchanger between the cooling tower and the chiller can add a layer of protection against the fouling of the chiller's condenser tubes, but at an added cost. This doesn't eliminate the need for water treatment of the tower, it just shifts the tower base of water from contacting the chiller's coil to the heat exchanger. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.